Okay guys, I'm going to just go through the final exam review packet kind of quickly, but just hope this will help you review. If you want to watch it on the bus before the test, it'll just kind of give you a nice refresher of everything we've done this year. So this says write out the converse, the inverse, and the contrapositive of the given conditional statement. Remember, this is if I am a goldfish, P, then I can swim. There's Q. The converse switches the order. The inverse negates it but keeps the order. The contrapositive negates and switches the order. So the converse says, let's switch the order. So if I can swim, uh-oh, my purple pen's dying. Let's see if I can get another one. If I can swim, then I am a goldfish. Okay. The inverse, keep the order, but we're going to negate. So if I am not a goldfish, then I can not swim. Okay? I'll let you guys do this one on your own. Number 2, based on the diagram, which of the following statements is true? Now remember, what's telling me that these lines are parallel. As soon as I know I have a parallel lines problem, I want to do some dots and some stars. So there's a dot, star, star, dot, dot, star, star, dot. And you'll notice all the choices are talking about 4 and 5, angle 4 and 5. So here's angle 4, here's angle 5. This has a dot, this has a star, which means they're not congruent. They add up to 180 degrees, and that's what the word supplementary means. Let's keep going. Given the conditional P arrow Q, if it rains, the field will be wet. Which of the following represents the converse? Well, we already talked about this before. The converse is just switching the order. Number 4, find the value of X that makes the lines parallel. Well, here's my keyword parallel. So that makes me think dots and stars. Remember, any 2 dots are going to be congruent. Any 2 stars will be congruent. But a dot and a star adds up to 180. They're supplementary. I have a dot here, I have a dot here. So that's what tells me I can set these 2 statements equal. I'm going to subtract 8x on both sides. I'm going to add 7 to both sides. And I'm going to divide by 2. Okay, number 5, which statement is true? So we want to figure out which pairs of lines are parallel. I'm going to do some dots and some stars. This is going to get a little crowded. We're just going to go straight through the order. Okay, so W is parallel to Y. So here's W, here's Y. On W, I have the 70 with the dot, and I have the 110 with the star. Well, these are supposed to add up to 180, and they do. Okay. X and Z. X has an 80 and a dot. Z has a 100 and a star. They're supposed to add up to 180. They do. So we got lucky that first time. Let me just show you why some of the other ones don't. So this is the correct answer. Here's W and X. So W is here. X is here. They both have dots. That means they're supposed to be the same. Those aren't the same. So you can kind of see how that would work. Okay, number 6. Given that ray KH bisects, remember bisect means to cut something into 2 congruent parts, or to in half, right? So GKH is 5x plus 12. HKJ is 4x plus 20. If this bisects the angle, it means these 2 halves have to be the same. I'm going to subtract 4x on both sides. I'm going to subtract 12 on both sides, and I get x equals 8. But it says solve for, this should really say the measure of angle GKH. Oh, man, mess up here too. If the measure of this is this, and the measure of this is this. Okay, so the measure of angle GKH is 5x plus 12. But now we know that x is 8. That's going to give me 40 plus 12, which gives me 52. Okay, next page. Okay. GH, segment GH has a length of 3x plus 4. HI has a length of 2x minus 12. GI has a length of 42. Okay. This is not the midpoint, so these parts are not the same length. But what we do know is that this whole thing plus this whole thing has to be 42. Think about it. If this were 10, you could figure out that this was 32 because 32 and 10 together give you 42. Same thing. 3x plus 4 plus 2x minus 12 is the whole length, 42. So that's going to be 5x minus 8 is equal to 42. I'm going to add 8 to both sides, and I get that x is equal to 10. And notice it just says, what's the value of x? We don't have to plug it back in. Okay. Here we have vertical angles. Vertical angles are congruent. Their measures are equal. So you're just going to solve that statement. Okay. Number 9, angle A and angle B form a linear pair. So here's angle A, here's angle B. A linear pair is, remember, with a straight line, everything's on top. So the measure of angle A is 55 degrees, so we want to figure out what the measure of angle B is. Well, 55 plus my unknown is 180. A linear pair adds up to 180, so my unknown angle is 125. Or in other words, the measure of angle B is 125. Okay, we can name an angle in multiple ways. The primary way is to use 3 letters, so I'm going to do EDC, angle EDC. If I could go backwards, angle CDE. I can name an angle by the number inside the angle. And if there's only one angle in the picture, I can name it by the vertex, D. Number 5, find the distance of the following line segment. Well, remember, if I want the distance of a line, and I have a coordinate plane, I can draw in that right triangle. This has a length of 3. This has a length of 1, 2, 3, 8. Here's my hypotenuse, right? So I can do 8 squared plus 3 squared equals x squared. And I'll let you guys solve that later. Okay. 12, find the midpoint of the following line segment. The easiest thing to do if you can plot your points is just look for the middle. So I'm kind of taking a look. I think that looks kind of like the middle, right there. Backwards 1, up 2. But I can check by using the midpoint formula. So this thing right here is backwards 5, up 5. This thing right here is over 3, down 1. The midpoint formula says x-coordinate, so there's the x-coordinate, there's the x-coordinate. An average of the y's, 5, negative 1. Okay. Negative 5 plus 3 is negative 2, divided by 2 is negative 1. Add those, you get 4 divided by 2 is 2. That's what we got. So you can also just eyeball it a lot of the time. Let's keep going. Solve for x. Okay. You'll notice that this is an isosceles triangle. When 2 sides are the same, the angles opposite will be the same. So this has to be 66. These 3 have to add up to 180. I really shouldn't do x. I'll call that y. Okay, so if I do 66 plus 66, I believe I get 132. Which means y is 48. Okay, so this angle right here is 48 degrees. Now, this 90 right here tells me that this angle and this angle together have to add up to 90. So if I subtract this from 90, I get 42 degrees for this angle. Well, notice these 2 sides are the same, so the angles opposite them have to be the same. If this is 42, that means that x also has to be 42. Determinant of each of the following can be the measures of the sides of a triangle, right? Yes or no? Well, in order to be the sides of the triangle, the 2 smaller sides have to be bigger than the biggest side. Well, 12 is not bigger than 5, so this is a no. Remember, the 2 smaller sides have to be bigger than the biggest. 13 is not bigger than 21. The 2 smaller, 6 and 12, have to be bigger than 13. Well, 18 is bigger than 13. Smallest to largest. Well, here's TUV. UV is 11. TV is 21. TU is 13. This is the smallest side, so this is the smallest angle. Medium side, medium angle. Largest, largest. Okay? So the smallest angle is angle T.
Ellery Damiano, would you please call the main office?
And then V.
Ellery Damiano, please call
And
the
then
main
U.
office.
Okay. Number 16, given the similarity statement, write the extended proportion. Well, the extended proportion just says, let's compare all the sides that go together. So notice we have triangle ABC. Well, all the side options are AB, BC, and CA. An extended proportion is just going to compare it with all the sides it goes with the other one. So AB, the first two letters, is going to go with DE. BC, the second two letters, is going to go with EF, the second two letters. And the last and the first is going to go with the last and the first. Now, you might have written this a little differently, like you might have done it in a different order, but make sure that the parts line up from the statement. Okay. Number 17, state if the triangles in each pair are similar. There are 3 ways to prove that triangles are similar. And they are SSS similarity, SAS similarity, and AA similarity. I'm going to go on a quick little side thing real fast. If I have 2 triangles, and this is, 5, 6, and 7, and this is 10, 12, and 14, these 2 triangles are going to be similar by SS similarity because all of their sides reduce to a ratio of 2 to 1, 2 to 1, 2 to 1. They have a common scale factor. If I have something that looks like this, and I know that this is 5 and this is 6 and this is 10 and this is 12, notice I have a relationship of 1 to 2, 1 to 2, but I only have 2 pairs of sides. But because of my vertical angles, I have that included angle. This would be an example of SAS similarity. If I have 2 triangles that look like this, and they have 2 pairs of matches with this matches with this, that's an example of AA similarity. So that's an example of each of these. Well, let's look here. The smallest needs to go with the smaller from this one, and the 2 biggers are going to go together. So 28 goes with 14, 26 goes with 13. If you plug these into your calculator, these are both going to reduce down to 2 over 1, 2 over 1. So are they similar? Yes. How do you know? Well, the sides that I had went together and I have that included angle, so that's going to be SAS similarity. Okay. I have FED, so here's F, ED. So it went from the vertical angle across the bigger side across the back. So I'm going to start at F, the vertical angle, go across the bigger side, and then go across the nothing side. So FKL. Okay. Find the scale factor. Okay, well, I'm just going to take the smallest. I'm going to take the mediums. And I'm going to take the biggest and put them together. So 5 with 10, 6 with 12, 8 with 17. Now, I made a mistake. This has been fixed since, but you'll notice this is 1 over 2, 1 over 2. This is not. So these are actually not similar, and that was a mistake I meant. They were supposed to be similar. Let's look over here. This side of this triangle goes with the full length of the side for this triangle, right? So I'm going to do 12, goes with 120. Okay. 9. I forgot what else goes together. So this 6 goes with this. So 6 from the small triangle goes with 60 from the larger triangle. They share this angle, but we're not going to worry about that for right now. If you type this in your calculator, you're going to get 1 over 10 and 1 over 10. So their scale factor would be 1 over 10. Okay, solve for the missing side of the triangle given that these triangles are similar. Okay, so we need to line up pieces. So DE, oh, there's nothing here. So ER, the second 2 letters, have to go with TR, the second 2 letters. So this goes with this. DR, the first and the last letter, go with SR, the first and the last letter. So I need to make sure that I go 10 with 25, oopsies, question mark with 20. Or instead of a question mark, I'm going to put an X. We solve this by cross multiplying. So 25x is equal to 200. I'm going to divide by 25 on both sides, and I get x is 8. The big difference here is this was similar, which meant I needed to set up a proportion. But here we're congruent, which means sides that go together are just the same. So it wants us to find the length of RS. Well, RS is the first and the last. So I need the first and the last. So RS matches up with RU, this. If this is 37, that means this is going to be 37. Similarly, UQ, the last two, SQ, the last two are going to be the same. This is going to be 52. I know it's not drawn to scale, but you want to pay attention to the congruency statement. Okay, complete the congruent statement. We have U, T, V. So I went from the one arc, across the 3, across the 2. So this is going to be A, C, B. Okay, well this is the same as AAS. This is the same as SSS, AA, HL, ASA, SAS, ASS, SSA. So for congruency, the big thing is I can't use the bad word, so it can't be this one. This is just it backwards, so that's no good. And then angle only works for similarity. So my valid ones are these. Make sure you have those memorized. Okay, let's complete the proof. We always start with given. Notice BC is already marked as congruent to ZC. DC is now marked with CX. They want us to say that BCD, this angle, is congruent to ZCX, so ZCX, this one. Well, that's true because those are vertical angles, so I can use the vertical angles theorem. Now I have 3 matching parts, so a side, and that included angle, the angle directly in between, so my triangles are congruent by SAS. I'm going to keep going. We're going to solve for x. This is a right triangle problem. I'm going to use a squared plus b squared equals c squared because I have 2 sides I'm solving for.